Actually, just one girl, so do that. Today we have with us the lovely Miss Savannah Stone, and we're going to do a lab. And basically, all I want you to do is measure the volume of a cup, and I'm going to make this as an assignment for all of my Algebra 2 students. I'm actually going to even do this with my Algebra 1 students, so this shouldn't be that bad. Can I see the cup that you're going to use? Awesome. That's a good looking cup. Okay, good. Let's go over some formulas that we know. What is the formula for the area of a circle? Do you know that?
Yeah. Pi times R times something? Divided by something?
Yeah. It's actually pi times r. Pi r squared, also known as pi r squared. You cool with that? Yeah. This is pi r squared. This is the area of a circle. So if I gave you the radius of that circle, you could tell me what the area is. By the way, do you have a calculator?
Yeah.
All right, you're going to need to get a calculator. So make sure you have that. If I told you that the radius, I'm just going to give you a test. If I told you the radius was 3, well, what is the area? If the radius is 3 centimeters. Keep in mind, this is Algebra 1 stuff. I'm just making sure you know how to use a calculator, because we're probably going to be using that today.
28.274.
Awesome. That's a good check. And if I told you that the diameter was 3, what would you do then?
Probably the radius, so 1.5 times.
There we go. Good. Yeah. All right. I'm not going to make you calculate it, but yeah, absolutely. You would choose a radius of 1.5. Good. What would be the volume of a cylinder, like a can? I'll tell you what it is. It's pretty simple. The area of a circle is pi r squared, right?
Yeah.
Well, all you do to get the volume of some kind of can, if you have like a can of soup or something like that, is you take that area, pi r squared, and you multiply it by the height that the can is. Does that make sense?
Yeah.
So, if I wanted to give you, like, if I gave you the dimensions of a cylinder, you could tell me the volume that would take up. Are we cool?
Right.
All right. Now, here's the problem, though. The cup that we're talking about, or show me that cup that you're using again. It's not a cylinder, right?
Yeah.
It looks very close to a cylinder, but the bottom radius is different from the top radius. So it's kind of a tapered cylinder, which I have no idea why they make cups like that. Like, why do they make cups where it flares up? Why don't they make cups so it actually flares in, so the base is bigger? Why would you make the base smaller? It just seems to me like it would be more unstable, right? But like every culture developed a cup, and every culture seemed to develop the same kind of cup. I have no idea why it flares out. It doesn't make sense to me.
Dump a bunch of water on their face.
What is that?
Maybe they want to dump a bunch of water on their face.
Yeah, I don't know. But maybe they like having their cups fall over. I don't know. All right. So we have something that is a kind of a tapered cylinder. It's like a cylinder that gets smaller, which isn't a cylinder anymore because a cylinder has right angles, and this one doesn't have right angles. Does that make sense?
Yeah.
All right. So the next equation I'm going to teach you is the equation for the volume of a cone. Now, a cone would be basically it looks like a shave ice cone. If you can think of a shave ice cone. So it's actually pretty simple. It's pi times r squared times h. Actually, you know what I'm going to put up? That's the volume of a cone. Can you see the chat bar, by the way?
Yeah.
All right, good. You know, Savannah, I hate to do this to you, but can you put the phone off of speaker?
Yeah.
I'm getting this weird thing where I sound like an alien. I apologize. Yeah, sorry. You're gonna have to hold it like that. I'm sorry. If that hurts your neck, you can put it back on speaker. That's fine. It's just I get this weird feedback on my phone that makes me sound like some kind of alien. All right. So check this out. The volume of a cone is pi r squared h times 1/3, or basically you take pi r squared times h and divide it by 3. What do you notice about the difference between the volume of a cylinder and the volume of a cone?
The volume of a cone would be smaller than that of a cylinder.
Yeah, how much smaller?
1/3.
1/3. I think that's really awesome, actually. I think that's really interesting. It's almost like I would expect the volume of a cone to be some kind of complicated expression, but it actually ends up being a lot more elegant than I thought it would be. You know what I mean?
Yeah.
All right. Let me share with you my computer screen because I want to start talking about where we get this idea of how we're going to end up getting the equation of a cup, which is what we're calling like a tapered cylinder, which is a weird concept, right?
Yeah.
Okay, so I'm going to share my desktop with you. I don't have the pen capability, so I guess I'll just find a cone and then see if I can share the desktop with you. Then I'll stop sharing it with you. All right. All right, let me know if you can see my computer screen. Can you see my computer screen?
Nope.
It says I'm sharing my desktop.
I can't see you. Or your desktop.
Move the
What?
I'm gonna have to turn off your webcam and then I will.
Oh, wait. Okay, keep
Do
going.
you see it now?
No.
Okay. I'm gonna turn off your webcam and then we'll start that one up again. All right?
Okay.
Okay, hold on. You can't see the desktop sharing. It says I'm sharing it.
There you are. What are you looking at?
Actually, you know what? I don't see it either, so maybe I'm not. I'll tell you what. Why don't you do this? Why don't I guide you through this thing? Turn your webcam back on. I thought that was cool.
Okay.
All right. I want you to go back to. I want you to go into Google. Let's do some typing. Look at a volume of a cone. Just type in volume of a cone, and we'll go into. I don't know. Am I in Google? I'm on Yahoo. Why am I using Yahoo? Oh, it's because I'm using Firefox today. Just so we're on the same page, I'm going to type in volume of a cone. Alright, cool. So I get this little picture of a cone. We cool with that?
Yeah.
And what I think is really interesting is it's pi r squared h divided by 3. So it's like a cylinder, but it's a cone, so it's actually only 1/3 of it. So apparently, if you take a cylinder, cut it into 3 parts, that would be the same as if you had a cone inside of that cylinder. Interesting. Weird, but interesting. If I turn that thing upside down, if I turn that shape upside down, it would look like an ice cream cone, or I guess for you guys in Big Island, it's a shave ice cup. By the way, I'm
Yeah.
curious to know, in Big Island, do they call it shave ice or ice shave?
Shave ice.
Yeah, there was a book I was reading about and it was trying to play itself off as super pidgin English or whatever, and he calls it, oh, the locals here call it ice shave, and I was like, oh gosh, no, they don't. Anyway, all right, so it's a shave ice cup. Okay, cool. All right, now imagine if all right, let's look up. All right, here we go. I want you to type this into the search bar. Volume of a truncated cone. Okay.
Okay.
And then click on the third image. In fact, I'll just copy and paste the image for you. Check that out right there. Let's look at that same picture. Okay, do you see what I'm looking at here?
Yeah.
All right. So if I want to take the volume of a large cone, which is, if you can think of the whole thing as a large cone, and I'm going to cut off the bottom part of that cone, okay?
Okay.
Then essentially I'm getting close to my truncated cylinder or my tapered cylinder. The picture that I have left over looks like this. Miss, I'm eating chocolate while I'm talking on the phone with you.
That's not chocolate.
All right, it's a
That's
cookie.
my breakfast.
Okay, it's a breakfast cookie. All right, try click on that. SwiftTutors.com,
Yep,
whatever.
I see it.
So that's the shape of what we're looking at. Cool. So this equation that we're going to get using, this equation that we're going to get for the volume of our cup. I mean, if I turn that image upside down, that would look more like the cup. I would have R1 being the base of the radius. I'd have R2 being the top of the radius, and I'd have the height of the cup being whatever.
Right.
If I turned this guy upside down, that would look exactly like my cup, a tapered cylinder. So where do I get this equation? Well, I get this equation from taking the equation of a large cone, got it, and then subtracting off the volume of a smaller cone, and that would give me the equation for my thing. So now what I want you to do is I'll look it up. Volume of a truncated cone. Which one do I like? I like these guys. These guys are pretty good. All right, check this one out. So, do you see the equation that they give for volume?
Hang on, it's loading.
Okay.
Okay.
And that's interesting to me because the volume is 1/3 pi, some thing inside parentheses, plus h. Now, it's not exactly r squared. It's a combination of having r1 and r2, depending on what r1 and r2 is. So you have, but it almost looks like the volume of a cone. You're just using a weird kind of combination of r's.
Right.
So it's 1/3 pi h times the radius of 1 squared plus the radius of 1 times the radius of 2 plus the radius of 2 squared. Okay. All right. So now with that in mind, I'm going to turn it over to you. I've done all the theory for you. Now it's going over to your face, and we're going to basically figure out the volume of the cup that you have. So turn it over to you. You have the string. You have the cup. You have a ruler. Tell me, what is the radius of the rim of the cup?
Okay. The radius.
You can turn your thing back on speaker because you're going to be doing most of the talking, and I'll just be watching.
No, I'll just use my phone.
All right. What's the radius of the rim of the cup? If it's all right with you.
3.75.
3.75. How'd you get that?
With a ruler.
No, show me what you did. I want to see that. All right. Here's I like that, but here's where I disagree with it. How do you know that you're going exactly halfway across? What I can see it, Mr. Dalday. I look at it and it's right there, right? I'm perfect. Everything I do is perfect. Everything I touch is perfect, so I know I'm doing it right. How do you know that you're cutting that thing exactly across the middle? That's what I'm saying.
I don't know.
Yeah, that's the problem. That's the problem I have. Here's what I would do if I were you. I had one student wrap a yarn around the top of the cup, around the rim of the cup. Try that.
Okay.
You got it?
No, it's very slippery.
Yeah, point the camera down so we can actually see what you're doing. I mean, you have a pretty face and everything. It's just, I mean, the whole point is to see the lab. Okay.
It does not want to work.
All right, that looks great.
It looks terrible. Okay.
All right.
There.
Okay. Now, take that string off. Make sure you're holding it in place so that you can measure the length of the rim of the cup. Unless, of course, you have a tape measure. Tape measure would really work for this game.
I do have tape measure.
No. I'll finish it off anyway. You already
We'll
did
just
it.
go with this because it's already done.
All right, what is it?
Okay.
That's a cute ruler.
I don't know where it came from, actually. It is 11.75
Inches?
Yes.
All right. I recorded it. 11.75 inches. So what is the radius?
Half of that?
Half of that?
No, not half of that. Take from the radius of a circle.
How many centimeters in a circle?
No, I'm talking to myself.
Okay. Now I'm going to ask you lots of questions, and I'll probably even like joke around with you. Please keep in mind that I think you're brilliant. Okay, I'm just going to joke around with you to joke around with you, but I'm not going to be like, well, I mean, I'm going to joke around with you to prove points, but it's not. It's more of a lesson for other people, not necessarily for you. Okay.
Okay.
We've developed a good rapport enough for me to joke around with you, right?
Right.
All right. So 11.75 inches. What is that a measurement of?
The diameter of the circle.
The
The top of the cup.
The diameter of the circle. No,
I mean,
it's not the diameter.
the circumference. I mean, whatever it's called. I can't remember. There's too many words.
No, you're right. It's called the circumference. The circumference. You're right. If you did measure the diameter, then you would half that. But that's not what we're measuring. We measure the circumference. So there's an equation that will relate the circumference to the radius. Do you know what that equation is?
I used to.
All right. If you don't know, I'll tell you what it is. It's pretty simple. C equals 2 pi r. The area is pi r squared. The circumference is equal to 2 times pi times r. Got it?
Okay.
Okay. So, if you want the radius, I have the circumference. I basically have 11.75 equals 2 times pi times r. Then what is the r? Use your handy dandy calculator.
Okay. 1.87.
All right, let me just double check that because I'm not sure. 11.75 divided by divided by 2 times pi. Okay, wait. Google is thinking. I don't know why it takes so long to think. I mean, come on, Google, you're a calculator as well. All right, you know what? I'm just going to type it in for me. What was your radius that you got?
1.87.
Perfect. All right, let's do that. Let's go with that.
Okay.
1.87?
1. Yeah. I
Okay.
think. Yep.
All right.
It said.
Which actually makes me think, Savannah, that your measurement of 3.5 was pretty off. When I asked you to measure
Probably.
the top of the cup, you told me you told me 3.5, right?
I believe so.
So that would give you 1.75 as the diameter of the cup.
Yeah.
But it's not 1.7; it's 1.87. So I'm
Right.
just saying. I mean, I'd rather go with accurate measurements here than inaccurate measurements here, if that's all right with you. All right, I'll tell you what. I'll give you a second. Why don't you measure for me the diameter, or give me the radius of the bottom of the cup using the lessons you already learned? So I'm not even going to talk you through it. I'm going to see if you remember what I told you. I'm going to try to figure out why my calculator isn't working. So, okay, wait, it's 11.75. All right. Apparently, 1.87 is correct, by the way.
Okay. Circumference of the bottom is. Wait, I'm stretching it. 9.25.
9.25.
9.25.
All right. Giving us a radius of what?
Giving us a radius of 1.47.
1.47. All right, cool. So, here's my next question. What else do you need to get the volume of a truncated cone?
The height.
The height. All right, cool. Measure the height.
This isn't gonna work.
Huh? What's that number?
About 4.75.
4.75. That's that.
Well, I don't know.
That's along the edge, right?
The edge. Make it easier. No, 4.5.
4.5.
Yeah.
All right. Here's something that I wanted to think about, because this is what I was thinking about. Is that's not exactly the height that we're looking for, is it?
Nope.
That's like the height.
of the wall.
Yeah, that's the height of the wall of the cup. That's not the height of the actual cup. The height of the cup would be as if we were measuring from the inside, the middle, all the way up to the rim of the cup, and we need to make sure that our ruler is exactly perpendicular, using a level or whatever. Yeah, I don't know. And how do we know whether our ruler is the level? You know what I mean?
Yeah.
All right. There's got to be a different way we can go about this. Oh, hey, it's a tape measure. All right. Yeah, but still, you don't know if that thing is perfectly level. So,
Not gonna work.
yeah, that's what I'm thinking. Okay, here's what I want you to do. Savannah, draw a triangle. on a piece of paper and then show it to me. Needs to be a big enough triangle. Don't draw some small rinky-dinky triangle. Good. Wait, no, I want a right triangle. That's not a right triangle, is it?
Right triangle.
Sorry, I should have been more specific.
Yes, you should have.
Actually, I'm going to change it one more time because I already see how you're drawing the triangle. Yeah, not what I want. Okay. Okay. I would like a right triangle where that bottom side is kind of short, is shorter, maybe about like a third of the bottom side. So it's kind of like it's got one really short side, one medium-sized side, and then the hypotenuse.
Okay.
Sorry, I should have been more descriptive. Oh gosh.
Like
Oh gosh. Yeah. I realized there's one. I'm actually probably going to have you flip the paper over and draw one more figure. Anyway, before you do that, let me tell you what to label that. On that triangle that you just drew, label the hypotenuse 4.5.
The hypotenuse?
That would be which side?
The long side.
Good, 4.5. Now label the bottom, the shortest side, 0.4.
Okay.
My question to you is, where did I get 0.4? You can understand where I got 4.5 from.
Yeah.
Where did I get 0.4 from?
You told me this, I just can't remember.
No, I never told you this. This is out of the box creative thinking. Because I'm going to venture to say, in order to figure out the height of our cup, all you need to use is Pythagorean's theorem to figure out the other side of that cup, or of other side of that triangle.
Okay.
That would be my creative, out of the box way of going about it. But my question is, where did I get the 0.4 from?
Oh, the top of the cup is bigger, the bottom is smaller, something that has to do with the different sizes of the circles.
There we go. That's exactly it. I mean, I guess the question the question I'm asking is, how much further does the top rim stick out from the bottom rim? Right?
Yeah.
And my answer is 0.4, because all I did was I just took 1.87 and subtracted 1.47.
Right.
We cool?
Cool.
All right, good. Do you know how to find the other side if you have the hypotenuse and one side? Do you know how to of a right triangle? Do you know how to do that? Do you remember Pythagorean's theorem?
Pythagorean theorem, I have to remember what it is. Something squared times something squared.
A squared plus B squared equals C squared.
A squared times B squared equals C squared. Right.
All right, and it's basically saying one side squared plus the other side squared equals the hypotenuse squared. C is always the hypotenuse. So really what I'm telling you to write down is, let's let B equal to our base. And so I'm asking you to write down A squared plus 1.47 squared equals 4.5 squared. I'm sorry, not 1.47. A squared plus 0.4 squared equals 4.5 squared. Right?
Right.
A squared plus 0.4 squared equals 4.5 squared.
Okay.
Cool? All right, solve that for me. Tell me what A is. I would not venture to do it in my head. I would probably use a calculator. Oh, you're using a calculator. Your calculator's a computer. I get it.
Calculator is computer.
All right.
That is true.
I better work on my side so I can verify that your answer is correct. What'd you get?
Not finished.
Dude, I'm finished already. I started way after you. Are you typing it in separately, like one at a time, and then figuring it out, and then writing down the number?
Wait, I have to. Okay, 11.25.
11.25.
That's what I got.
I
But
mean,
that can't be right.
how can that be right? I mean, it's got to
It
be
can't.
smaller than 4.5.
I did it wrong.
Okay, all right, here. Check this
I'm
out.
gonna do it wrong.
Copy and paste what I did into Google. Copy
What?
and paste exactly what I typed to you into Google. You got to learn the art of using a calculator.
I'm not very good at it, apparently.
You take the 4.5, you square it. You take the 0.4 square it. You subtract those two, and then you take the square root of it. I have Google basically in that command. I have Google doing all of those three things at one time. And the answer is
4.4? 8?
4.482. Awesome. All right, so that would be our height of the cup. Cool?
Okay.
Now, let's see if you can hone in on your calculator skills and tell me, pray tell, what is the volume that that cup should hold? I'll give you a hint. Here's the formula. It's 1/3 pi r1 squared plus r1 times r2 plus r2 squared, close parentheses, times h. It's the volume of that. It's the I gave you that website for the truncated cone.
Yeah.
That's the one.
Okay.
That's the equation I want.
Right.
Please use your mad calculator skills and tell me what your answers are.
My failing math calculator skills.
No, they're mad. They're mad calculator skills.
Um.
Oh, you know what? I hate to do this to you, but can I ask you a favor real quick?
Yeah.
Okay, my favor is this. Using inches is dumb. I know that that's the only thing you have on your ruler, but it's kind of dumb. I would much rather use centimeters. Can we convert these to centimeters? It's really easy. I'll actually do it for you.
Oh.
All right. 1.87 inches is 4 point... Here, I'll just copy and paste this for you. Here's the numbers I want you to use. The upper radius is that. Okay. The lower radius is apparently this. And the height that we ended up getting is this height. Is that. All right. I just would rather use centimeters. They're cleaner units.
Okay.
All right. So do me a favor and plug in your numbers into there.
Okay, so it'd be 1/3 times 5 parentheses 4.7 squared. Plus
All right, I got my answer.
well, you didn't have to write it down.
Well, Mr. Daldy, good for you.
Good job.
I get it. Sarcasm.
You're a teacher, you're supposed to get.
I'm supposed to what? Use a calculator faster than you?
Yes.
Okay. I don't see the. I don't see the logic in that, but all right.
Okay.
Okay. I did it again. Did
You
you get
did
your
it.
answer yet?
You can't have done it. You did it again.
Yes, I did
Why
it
am I
again.
so much slower than you? Maybe you have a better calculator than me.
No, I don't have. I'm using the same calculator as you. I know what you're doing, and it's a skill that I realized I'm actually okay. This summer, I'm going to teach my 5th grader, my 10-year-old, algebra, and one of the skills I'm going to work on with him is using a calculator. And I realized that it's an algebra 1 skill. It's actually a pre-algebra skill. Like you do algebra to get all these complicated expressions, and then you figure that like students can use a calculator. The sad part is students can't necessarily use a calculator. Anyway, I'm sorry. I'm just ranting. I'm not saying you're slow. I think you're incredibly brilliant. You need this skill. You know, maybe I should work on this, but I don't have time because I got to work on stats with you. So, anyway, are you done yet?
Well,
All right. Here's what you're doing. Okay, I'm going to guess what you're doing. You tell me what you're telling me. You're calculating out what is R1 squared. Then you'll write down the answer, right?
yeah.
Then you figure out, okay, what is R1 times R2? Write down the answer. What is R2 squared? Then you add them all up. Okay, what is that? And then you're going to multiply that by 1/3, multiply that by pi, then multiply that by h. And each step, you got to write down these numbers, right?
Yeah.
I did this.
You just plug the whole thing in, but the calculator gets screwed up sometimes, doesn't it?
It does. It does get it screwed up if you don't know PEMDAS. But if you do know PEMDAS, please excuse my dear Aunt Sally, and learn how to put in the parentheses correctly, it doesn't get screwed up. That's the whole point of doing PEMDAS. So anyway, also keep in mind, and don't hate me for this, but you know that original, the original website I gave you, the Kaysen one? It's this one right here?
Yep.
If you look at that website, it asks you, well, what is the lower radius, what is the upper radius, and what is the height, and it actually calculates it all out for you.
It does.
Yeah, it does. It does. And that's how I figured out the first time, the answer. But I wanted to confirm that I was typing into the calculator correctly. If I were to type it into the calculator, so I did it independently, and you can copy and paste what I typed in, and that's you'll get the same answer. It's 646. Cool?
Okay.
Okay, so here's what we got. Um, the measuring cup that you have, I don't have a whole lot of time, so we're going to go through this a little bit quicker. The measuring cup that you have, is that measured in, does it have milliliters on it, or is it just cups?
I think it's just. Wait, the other side has milliliters, yeah.
The other side is milliliters. Okay, all right. What is the smallest, which one has the closest lines on it? Is it the milliliter side?
Yes.
Okay, cool. What I want you to do is, the reason why I asked you to convert inches to milliliters is because right now what we have is our answer is 646, right? 646.6132, blah, blah, blah.
Yes.
Of course, mathematically that's stupid because, like we didn't measure things up that accurately. So why don't we just go with 647?
Okay.
But what is this measured in? What's the units on our number, 647?
Centimeters?
Centimeters, just centimeters, 647 centimeters?
Cube.
Cubic centimeters, thank you very much. I mean, I know that it's a dumb thing, but I mean, it's what I'm teaching my fifth grader right now. I'm like, I'm saying like, what's the volume in here? And he says 647 centimeters. I'm like, so is like what, a volume of hair? There's like a hair that's 647 centimeters that fits in here? I don't understand. What he needs to understand is, having centimeters cubes makes a difference. All right, let me show you the conversion of 1 centimeter cubed to milliliters. It's very simple. 1 centimeter cubed is equal to 1 milliliter. In fact, that's how they define a milliliter. They just take a cube and chisel it down to be 1 centimeter by 1 centimeter by 1 centimeter, and they say, this is the volume of 1 milliliter. Does that make sense?
Yes.
So, how many milliliters should our cup fill up? Come on, Savannah, say it.
Yeah. Wait, I pushed the wrong button.
What buttons are you pushing? Okay, all right, whatever.
A really big number.
A really big number? What are you talking about?
70846.
Now I'm curious. All right. Finish off your thought. I warn you, I'm probably going to burn you on this one, but finish your thought.
No, I don't want to finish it.
No, tell me the number. I want to know what you're doing. At least I know. That way I can point it out. And I'm not trying to point it out to like put you down. I'm trying to point it out so that I can basically help other students.
Okay, well I got 270840023.
Okay, all right. Where did you get that number? Did you multiply 647 and cubed it?
Yeah.
No. We're measuring this in 647. It's already measured in centimeters cubed.
Okay.
So if 647 centimeters cubed, and for every centimeter cubed you have 1 milliliter, and we have 647 cubic centimeters, then here's how much milliliters we have.
Okay.
We have 647 milliliters. The
That's
reason,
easy.
yeah, it was easy. That's why I kept typing up 647 on top of the computer screen and asking you to say it. But I'm glad you brought that up. No, yeah, I mean, so do you understand where we're going at here?
Yeah.
Okay, all right. So you're telling me, in theory, there should be exactly 647 milliliters of water in that, or that can fit in that cup. Why don't you fill up the cup? Fill it all the way up to the top. Don't spill anything on your computer. And then I want you to pour it inside the measuring cup and tell me exactly how much water you have in the measuring cup. Huh, that's weird, by the way. Did you notice the big cup doesn't hold as much water as a small cup?
I didn't fill it up all the way.
I don't know.
It's weird.
That is weird. You gotta fill it up more. Sorry.
Okay.
I'm gonna make you go and get more water. Why is that? That's crazy.
I don't know. Weird. It's giant cup. Maybe it's just fat. The little one's just fat.
There we go. There we go. Careful. All right. All right. I want you to take all that water and fill it up inside of your measuring cup, and let's see if it worked. Measuring cup. Thank you for showing us and being real demonstrative while holding a phone in your ear. Perfect. All right. What's our number?
Very close to 550.
Whoa! That is a significant difference. Okay, all right. By the way, folks, whoever's watching this YouTube video, I didn't have her prep that, so I didn't know that that's going to be the number. But that was the last time we did it. It was really accurate. What I'm actually kind of curious to know is, here's what I want to know. Then is, what is the percent? I'm going to come up with a way for you to measure the percentage of your measured volume versus your actual your predicted volume, and then see what the number is. Tell me.
The cup doesn't go all the way to the bottom, you know.
Actually, I was just going to ask you. Tell me some ideas as to why you think that answer was so grossly wrong.
Oh, well, that's my idea.
I agree with you. The cup doesn't go to the bottom. You measure the radius at the bottom, but I guess what you should have measured is the radius at wherever it is at the bottom of that cup.
Yeah.
Also, your height is grossly different too, right?
Yeah.
The height that you should have measured should still be the wall, because I think that's still the most accurate way, but maybe we should measure the inside of the cup.
Right.
Or at least the height up to where it goes to. I could hang with the idea that bottom of the cup, the glass part, the solid part that thing doesn't fill up, that is about 100 milliliters. I could hang with that.
Yeah.
Here's another thing. You measure the outside. We didn't count the volume of the actual thickness of the glass. Right? This would be exactly accurate if we're talking about a paper thin cup.
Right.
All right, here's my last thought, okay? You spilled some water.
I did spill a little bit.
Yeah, see? There we go.
It's not a very poury cup.
Well, yeah, it's not easy pouring a cup, holding a phone, and all that kind of stuff. Actually, you know what? I think if I'm going to do this again, I'll probably have the students use like a paper cup, because paper cups usually go all the way down to the bottom, or maybe even one of those red plastic cups, because those go all the way down to the bottom. And then also, that's how I would recommend to be more accurate on this. But you did an amazing job.
Thank you.
All right. Thank you very much, Ms. Savannah Stone. I'll talk to you later. Everyone should thank you for all of your help.
I had a question about the Function 6 Part 2 quiz.
All right, let me stop this video, and then I'll work on the Function Quiz Part 2 with you.
Okay, thank you.